Hi there, today we are looking at question 16 of HSC Mathematics 2016, paper part A. A particle moves in a straight line, its velocity v meters per second at time t seconds is given by v is equal to 2 minus 4 over t plus 1. Part 1, part I is asking for find the initial velocity. Part 2 is asking us to find the acceleration of the particle when the particle is stationary. And part 3 goes like that by considering the behavior of V for large t, sketch a graph of V against time for t greater than 0, showing any intercepts. And finally, part 4, find the exact distance traveled by the particle in the first 7 seconds. Alright, for part I, they are asking us to find the initial velocity. To find the initial velocity, we substitute 0 for time in the equation they have given for the velocity, which is v is equal to 2 minus 4 over t plus 1. And as t is equal to 0, v becomes 2 minus 4 on 0 plus 1. V is equal to 2 minus 4 on 1, and v is equal to 2 minus 4. Resulting in v is equal to minus 2 meters per second. So a negative velocity means that the object or the particle is moving to the left. So initially the particle moves to the left. Okay, I've got this answer here in case we need that. For part 2, find the acceleration of the particle when the particle is stationary. To get to acceleration, we know that we need to differentiate velocity with respect to time. So acceleration is derivative of velocity with respect to time. And velocity is 2 minus 4 on t plus 1. To make it a bit easier to differentiate, I write t plus 1, which is in the denominator, with a negative power, which is 4 times t plus 1 to the power of minus 1. Alright, now when differentiating that find acceleration, we know that the derivative of any constant is 0. Minus 4 stays as is a constant times by an expression. And that power goes down and multiplied, then we bring down the power of the bracket by 1, making it minus 2, and we multiply by the derivative of the expression inside the bracket, which is in this case derivative of t, which is just 1. When we simplify that, that becomes 0, minus times minus becomes plus, 4 times 1 is just 4, and t plus 1 to the power of minus 2, and times by 1 doesn't make any difference, so we just drop it. I can go back again to write it as a fraction, this time with the power of 2, because the power of this bracket is minus 2, giving me the acceleration equal to 4 times 1 over t plus 1 squared, and then that becomes 4 over t plus 1 squared. That is the acceleration at any time t for this particle. However, they are asking us when the particle is stationary. So to find acceleration when the particle is stationary, as acceleration is given in terms of time, I need to find the relevant time when velocity is 0. So velocity is that, put it equal to 0, becomes 0 is equal to 2 minus 4 on t plus 1. Take this to the other side, this bracket, this fraction, and change its sign from negative to positive. Then cross multiply or times both sides by t plus 1. You end up with 4 equal to 2 times t plus 1 in the bracket. And you can divide both sides by 2, giving you 2 is equal to t plus 1 and 2 minus 1 to get to the t, and that gives us t equal to 1. So when t is equal to 1, the particle is stationary. Now I sub that t equal to 1 at the expression for acceleration. So acceleration is equal to 4 over t, which is 1 plus 1 squared. And I end up with 4 over 4, which is 1. Okay, yeah, that becomes 2 squared, 4 over 4 is 1. So my acceleration is 1 meter per square second. Alright, that is for part 2. I write the answer again here in case we need it at the next stages. Part 3. By considering the behavior of V for large t, sketch a graph of V against t for t greater than 0, showing any intercept. Basically, we got to see what happens to velocity when time goes towards infinity. When time goes to infinity, what will happen? T plus 1 also will go to infinity, because infinity plus infinity again is an infinity. Alright, so then what will happen? 4 over t plus 1 will go towards 0, because any number divided by infinity will be 0. So that will approach 0. So that means that V equal to 2 minus 4 on t plus 1, when time goes to the infinity, will approach, remember that approaches 0, so it becomes 2 minus 0, which is 2. So your limiting velocity is 2. So that means that as the time goes by, you will get closer and closer to 2 meters per second, but you will never reach it. Which its graphical meaning is you have an asymptote at v equal to 2. Okay, now they are asking us to sketch that. We know that it's going to have an asymptote at v equal to 2. To sketch that, I put v on the vertical axis and t on the horizontal axis. And I know that I have an asymptote at v equal to 2. And we know that the velocity was 0 when the time was 1 at from previous stage. So when time is 1, velocity is 0. So that means it is a point of my graph. And when the initial velocity, we showed that is equal to minus 2. So initial velocity was minus 2. Alright, so this is telling me that the graph will look like this. But you can also look at it from a different angle. This, you know that y equal to, for example, 4 over x plus 1 is a hyperbola. And because this is negative, that will be a hyperbola in the fourth and in the fourth and second quadrant. And this is the hyperbola of minus 4x shifted to the left by 1. And also, as you have that 2 here, shifted up by 2. That's another way that you can look at it. So basically you draw a hyperbola and then you erase, you give it the shifts that you need. You have 2 shifts. One is along the t-axis to the left by 1, and the other one is along the v-axis 2 up that you have it here. And then you can get rid of the negative part of t, because usually we don't consider time to be a negative value. Alright, that is for this. And eventually find the exact distance traveled by the particle in the first 7 seconds. One way of looking at that is considering that distance traveled is equal to area bounded between the v versus t graph and the t-axis. Okay, so we got to find the area in this, and because they are asking in the first 7 seconds, if this is my 7 second, that's one part of my area, that's the other part of my area. But because this area is under the time axis, I need to take its absolute value. So this means my x displacement is equal to integral of 0 to 1. We said that to find the area, you know that you need to integrate, so v dt, so that's going to be v dt. Of course, we got to take its absolute value, as I said, because this area is under the time axis. Plus, from 1 to 7, v dt, this one is above, so I don't have to take its absolute value. Okay, so that's absolute value 0 to 1, and velocity was 2 minus 4 on t plus 1 dt plus 1 to 7 2 minus 4t plus 1 dt. Okay, so first I do the first part of the integral and then I do the second part. So basically, let's call this A1, let's call this A2, area 1, area 2. A1, A2. I find them separately and then I A1 is equal to integral 0 to 1, 2 minus 4t plus 1 dt. And we need its absolute value. So A1 is equal to integral of 2 dt is just 2t minus, this is a case where your when you have a case where you are integrating and you have a derivative over the original function, you know that your answer is ln of the original function, okay, plus 0. Alright, so when you're integrating the fraction where the top is the derivative of the bottom, the answer is ln of the bottom. So we use that for this. So I have t plus 1, the derivative of that is just 1. So I have it actually, but 1 times 4, so that 4 is just a constant, I times it by that. 4 times ln t plus 1. And then that becomes from 0 to 1, of course, absolute value. So A1 is equal to, if I sub in 1, it's going to be 2 times 1 minus 4 times ln 1 plus 1. Then minus, if I sub in 0, it becomes 2 times 0 minus 4 times ln 0 plus 1. And remember again, we're talking about the absolute value. So A1 becomes 2 minus 4 ln 2, then minus, that is 0, and minus minus becomes plus, so plus 4 ln 1. But remember that ln 1 is 0. ln 1 is 0. That will give me 2 minus 4, absolute value of 2 minus 4 ln 2. Okay, so as we said, this value inside is negative, and the absolute value of that will be negative of inside. So 2 minus 4 ln 2. You can try by putting that in the calculator, and you'll see that you end up with a negative value. And that becomes 4 ln 2 minus 2. That is for area 1. Okay, so I write it down here. Area 1 is equal to 4 ln of 2 minus 2. Now we find the area 2. Area 2 is integral of 1 to 7 of 2 minus 4t plus 1 dt. So again, integral of that is 2t minus 4 ln t plus 1. 1 to 7, so I sub 7. Comes 2 times 7 minus 4 ln 7 plus 1. Then minus, now I sub 1. And I got to put in the bracket because I'm taking away the whole. So 2 times 1 minus 4 ln 1 plus 1. Okay, that gives me 14 minus 4 ln 8 minus 2 minus plus 4 ln 2. Which simplifies 14 minus 2 is 12 minus 4 ln 8 plus 4 ln 2. That is my area 2. Now to find the total distance, I need to add them up. Area 1 was 4 ln 2 minus 2. Now we're adding this, plus 12 minus 4 ln 8 plus 4 ln 2. Four ln 2 plus 4 ln 2 is 8 ln 2. And 12 minus 2 is 10. So we end up with 10 plus 8 ln 2 and minus 4 ln 8. Alright, and what I can do, I can turn this into also ln2. I can write 8 as 8, I can write as 2 to the power of 3. And you know that when you take in log, the power comes in the front. So you end up with x is equal to 10 plus 8 ln 2 minus 3 times, so it becomes 4 times 3 ln 2. So that gives us 10 plus 8 ln 2 minus 12 ln 2, and x is equal to 10 minus 4 ln 2. That is the displacement or distance traveled in the first 7 seconds in meters, because the velocity was given in meters per second. Thank you for watching.